Similar triangles end up being especially useful for a surprising variety of word problems, especially when you get into calculus and classes like that. So what they are, similar triangles are the same shape but different size. Okay, so same shape, right? Exactly the same shape, but the different size. They are different sizes. Different size. Okay, so something like this. Believe it or not, these are the exact same shape, but clearly one is bigger than the other. So let's label the big one with capital A, capital B, capital C for the sides, and little one with small a, small b, and small c. The cool thing about similar triangles is that they have this neat proportion. It goes like this. If you divide big A by little a, that's the same thing as dividing by big B by little b, which is the same thing as dividing big C by little c. Another way to look at it, or you can go the other way, you can say, let's do little a divided by big A. Well, that's the same as dividing little b by big B, which is the same thing as dividing little c by big C. Okay, so these two simple equations really have vast applications. Let's start with some easier ones just to get our feet wet with some of these ideas. So I'm going to do my best to draw two similar triangles here. So maybe something like this. Okay, so there's the big one, and then let's draw a replica of it. It'll be a smaller one. Okay, so pretend those are exactly the same shape but different sizes. Okay, and then maybe we have some distances here, like, I don't know, 20, let's do 18 and 12 here. And over on this little one, we'll have 4x and some kind of fraction, 20/3. Okay, so our goal, as often in an algebra class, is to find x. All right, find x. Okay, well, let's use one of these equations. It doesn't really matter if what we're calling A or B or C or any of that. You compare the similar sides. So notice that this x side goes with this 18. So we'll say x is to 18 as equals, and then you just pick another side. Let's do this side here. 4 and 12 go together. So 4 is to 12. Okay, and now we have a nice proportion. We solve that by cross multiplying, right? So we cross multiply up like so. Okay, so that gives us 12x equals, what is this, 72? And dividing x by 12 gives 6 right there, 6. And then if we had units, you'd add on the units, but we don't in this case. Okay, and there are a great many different ways we could have solved the same thing to get that answer, right? Let's just try the same one, but a different way. Let's do, well, x has to get compared to 18, so we're stuck with that. But this time let's do big to small. So we're doing 18 to x, okay? And now we need to compare big to small again. So let's do something, let's go really bizarre. Let's do 20 to 20/3. Okay, so we're doing big on top, small on the bottom. Okay, so 20 to 20/3. That's a bit harder way to go. I picked the hardest possible way to solve this thing, but a proportion is still set up and it will still work. All right, let's do it. Let's cross multiply. So I'll go up like that and up like that. Okay, so we have 18 times 20/3 equals x times 20. All right, let's simplify out some things here. 18 divided by 3 leaves us with 6. I'm just going to leave this as it is for a minute here. We have 6 times 20 equals x times 20. Well, if we divide both sides by 20, we get 6 equals x again. Much different path. We got to the top of the same mountain there. Okay, so a lot of versatility with similar triangles. You can see why they'd be useful in solving at least some word problems, and then I think as you go forward with your studies, you'll be surprised at how many word problems you can solve with similar triangles. Let's try another one. All right, draw some similar triangles here. Say that'll be our bigger one, and then here's our smaller one. Okay, 12, 10, and let's do 5 and y. So why don't you try this one? It'll be a fraction, by the way, so don't be too worried if you get a fraction. Pause the video, solve for y, and then let's compare notes in a minute. Okay, let's see. So I'm going to compare small to big, because that keeps my variable on the top. Anytime we can keep the variable in the numerator, it's going to make things a little easier, but it's not the end of the world if you ended up with the variable in the denominator. Okay, so I'm going to do y is to 10 as, and we're comparing small to large, so let's compare 5 to 12. We're not left with many options here. Okay, so as 5 is to 12. All right, cross multiply up, and it shouldn't be far from here. 12y equals 50, so y equals 50 twelfths. Well, we can definitely get a 2 out of both of those, so how about 25 sixths? Right, 25 sixths would work. If you really wanted to go to mixed numbers, you could. Right, 6 into 25 is 4. Right, goes in 4 times. 24, subtract, we get 1. So 4 and 1/6.